Hello students, welcome to my channel Engineering Education. Please subscribe my channel. Thank you. This lecture is about experiment number 7, power plants lab. The title of the experiment is to determine the energy transfer in engine/generator system. The objective of this experiment is to determine the energy transfer in engine or generator system. Apparatus used is miniature steam power plant. The diagram of miniature steam power plant is shown over here. We have demonstrated this in experiment number 2, demonstration of miniature steam power plant. Safety procedure and maintenance. First of all, before performing any lab activity or experiment, we have to follow the safety tips and the safety guidelines while working inside the labs. So the following points should be noted and strictly adhered to in the interests of running the equipment safely. First, the water level in the boiler should always be visible in the gauge glass. The recommended safe working pressure should never be exceeded. The range of pressure is from 0 to 6 for this apparatus, but the safe operating pressure is from 0 to 3.5 or 4 to perform experiments. The boiler, when operated, must always be fitted with a safety valve. Here is safety valve in the boiler. The valve after use should be cleaned periodically, and if signs of water or damage are detected, the complete safety valve should be replaced. In the course of time, the safety valve spring may be deteriorated by corrosion or fatigue, causing the valve to lift at a lower pressure than the one intended. In these circumstances, the spring must be replaced by a similar one to the original. With the passage of time, here is some fatigue occurs in the spring due to excessive use, so it must be replaced after some time to work properly. Number 4, the gas flame can be seen through the base of the boiler. It is essential that throughout the operation of the boiler, the operator observes the state of the burner. If the flame goes out, the gas supply should be switched off. The flame should not be reignited until all gas has dispersed. The burner will become very hot in operation, and serious burns will result if anyone touches the burner, boiler or steam lines. So during performing the experiment, students are not permitted to touch the steam lines or any part of the steam power plant after the system has been in use, and then shut down. Oil the engine by using the lubricator that is fitted. Number 6, always keep the boiler and its fitting, water gauge, etc. clean. Number 7, the dynamometer drive belt should be kept clean, dry and free from oil contamination. The tension can be adjusted by moving the dynamometer and bracket on the slotted mounting holes. The tension should be just sufficient to provide a slip-free drive. Avoid excessive tension, as this increases the friction power lost in the drive and may cause damage to the bearings. Ensure that the dynamometer and engine center lines are kept parallel. This is essential that the dynamometer pulley and the steam engine, they are in line. they are parallel with each other to transmit power from the engine to the DC generator. Running procedure. When carrying out a test, fill the boiler with water to the top of the water gauge glass and conduct the experiment in the time taken for the water level to fall to the bottom of the water gauge glass. By using this method, the boiler steam pressure can be maintained as no cold water is emitted to the boiler. During experiment, water is not allowed to feed to the boiler because the experiment is affected and the readings which we will take will be affected. So during performing the experiment, water is not permitted to add to the boiler. Do not let the water level below the level of the side glass, as there is risk of damage or explosion if the boiler runs dry. So there is safe level of water inside the boiler. We have to monitor that level during experiment. If the water dries inside the boiler, then we must stop the apparatus immediately. The steam engine is loaded by switching load onto the DC generator by means of the lamps. Lamps 2, 3 and 4 use 90 mA at 6 volt and lamp 1 uses 180 mA at 12 volt. Switching the lamps provides a range of loads. The voltmeter and ammeter on the control panel are available to make precise measurements of output of the generator. Engine speed is measured using the handheld optical tachometer. Set the gas flow rate to maintain a steady boiler pressure. Don't let the pressure increase above 4.6 bar or 3.5 bar to 4 bar. This is the safe pressure to operate the boiler. The safety valve may release very hot steam above this pressure. So we should not exceed the pressure beyond 4 bar or 4.6 bar. Experimental procedure. Carefully read all of the instructions provided within the lab. If you don't understand any of the instructions or any of the warnings, obtain clarification before you commence. Always observe the burner's flame water level. Immediately switch off the gas supply if the burner gas out. Remember, the burner is very hot. Add water by using the feed pump if the water level falls below 1/4 of the side glass. For any help, the corresponding lab technician or lab assistant or lab instructor must be contacted to resolve any issue during experiment. Start the cooling water flow through the condenser as instructed. Light the glass burner as instructed. Allow the steam pressure in the boiler to rise to 4 bars and then start the engine as described in the starting procedure. Switch the bulb 1 to load the engine. Adjust the fuel flow to hold a constant boiler pressure while the generator is producing at a voltage of approximately 9 volts. When the system is stable, start the test period by collecting the condensate and taking the readings. Condensate may be measured by weighing the deposit over a fixed period of time, normally 3 minutes, or alternatively by measuring the time required to fill a fixed volume of 100 milliliter. Take further sets of readings at say 1 minute intervals, and when the test is finished, remove the source of heat to the boiler. Check that there is sufficient water in boiler for further test. Select a different load on the DC generator and repeat the experiment. When the experiment is performed, shut down the boiler according to the shutdown procedure mentioned here. Shutdown procedure is: first, we have to remove the load from the DC generator by switching the lamps out of the circuit. turn off the gas supply which is coming to the boiler. Allow the engine to run until the steam pressure in the boiler has fallen to a safe level. Close the boiler steam valve. So this is the shutdown procedure. Allow condenser cooling water to flow until all the heat has been carried away, and then turn off the water supply. When the system is cold, then drain the boiler tank's lubricator, open engine cylinder's drain, remove engine pulley belt, and disconnect gas supply. Oil all mechanical parts. The oil available is cylinder oil suitable for engine and bearings lubrication. During experiment performance, students are advised to take the observations. So as we are going to determine the energy transfer in engine generator system, so for that we need some readings. First is steam pressure at inlet of engine. Second, steam pressure at exit of engine. Steam temperature at inlet of the engine, and steam temperature at exit of the engine. Temperatures are denoted by T4 and T5. So this is the engine and this is the generator. Here we have steam as an input to the engine, and here we have output of the engine. Similarly, output from the engine is input to the generator. So this is the input and this is the output of the generator. Some power will be lost due to radiations. We will also try to find that amount of energy which is lost due to radiation. So the readings here for this experiment, we have observed that for steam pressure at inlet of the engine is 1.5. 2 times readings were taken and then average is 1.5. Similarly, for any value to read from the equipment, we have to take that value from 2 to 3 times or 4 times, and then we take the average value to make correct or appropriate calculations. Similarly, the steam pressure at exit of the engine is 1 bar, and steam temperature which is entering to the engine is T4, and that is 130 degrees centigrade. Steam temperature, the steam which is exiting from the engine is 106 degrees centigrade. So for these readings, we have steam input to the engine T4 130 degrees C. The mass flow rate is 40 gram per minute as calculated in the previous experiments, and the absolute pressure is 1.5 bar. So to find the energy in steam input to the engine, we have the expression m dot s into corresponding enthalpy at that temperature and pressure. Pressure is 1.5 bar and temperature is 130 degrees centigrade. So to find the energy in steam which is input to the engine, we have the expression m dot s into hg plus cp into T4 minus Ts, where hg is the saturated vapor enthalpy of this steam, cp is the specific heat of steam, T4 is the temperature 130 degrees centigrade, Ts is the saturation temperature at 1.5 bar. So these are the values which are captured from the steam tables. This is pressure in kilopascal. So 150 kilopascal is nothing but 1.5 bar. So at 1.5 bar we have these values. This is the saturation temperature, Ts 111.35. This is the corresponding other values. Here we need values which are mentioned in this expression. So Hg is 2693.1, Cp for this is 1.9 kilojoule per kilogram per Kelvin roughly, because T4 is 130 degrees centigrade, so converting it into Kelvin we get 403 Kelvin. So 403 Kelvin is almost near to 400 Kelvin, so we have the Cp value 1.901 or just 1.9. So putting these values in this expression we get the energy in steam which is input to the engine. So m dot is 40 by 60, converting mass flow rate from gram per minute to gram per second, and this is 2693 joule per kilogram per Kelvin, plus Cp is 1.9, T4 is 130 degree, while saturation temperature Ts is 111.4. So simplifying these values we get the value 118.89 watts. So this is the energy in steam which is input to the engine. Now at output we have steam exhaust from the engine. So for that we have T5 106 degrees centigrade, mass flow rate is same, that is 40 gram per minute, pressure is 1 bar absolute pressure. So again we have to find the energy in steam which is exiting from the engine, and that is m dot s into corresponding enthalpy at that pressure and temperature. Here pressure is 1 bar and temperature is 106 degrees centigrade. Again we have a mass flow rate value which is 40 gram per minute, pressure in kilopascal is 100 kilopascal which is 1 bar. This is the saturation temperature 99.61 or 99.6. 2675, this is the saturated vapor enthalpy, and the value of Cp for this temperature T5 106 degrees centigrade is almost equal to 379 Kelvin, which is almost near to 375 in this table. So its rough value is 1.89. So putting these values in this expression, again these values have been extracted from the steam tables. So putting these values in this expression we get 40 by 60, converting mass flow rate into from gram per minute to gram per second. This is the saturated vapor enthalpy. 1.89 is the specific heat capacity, 106 is the T5 temperature, and this is the saturation temperature 99.6 degrees centigrade. So simplifying this we get the energy in steam which is input to the condenser or which is output from the engine is 1791.39 watts. Now input to the generator. How we find input to the generator? Generator input is equal to generator output divided by generator efficiency. Generator efficiency is defined like this: generator output divided by generator input. So in this case we take the ratio of powers. So to find the generator input, we will multiply the generator efficiency with the generator output. So for this generator which is fitted in the apparatus, for this generator we have 70% efficiency. So generator efficiency is 70%, and the output of the generator is measured like P is equal to IV. So I is the current and V is the voltage. So I is 0.2 ampere while voltage is 8 volts. So this is the output of the generator. So multiplying this we get 1.6 watt. So rearranging this expression is, suppose generator input is equal to VI is 1.6 and generator efficiency is 0.7. So we get the value 2.28 watts. So this is the input to the generator. Now radiation from the engine, energy radiation. So this is the input to the steam engine and this is the output from the engine. Again this is input to the generator. So we will subtract the energies of the generator input and the steam engine exit energy of the steam. So we will get the energy to radiation and that comes out 25.22 watts. So energy is lost due to radiation and the quantity of that radiation is 25.22 watts. So this is actually, we have calculated it. This is the generator input and this is the generator output as we discussed, 1.6 watts. This is all about experiment number 7 of power plant lab. Thanks for watching. Please like and comment on my videos. Also subscribe my channel to get new videos.